Hello there, this is Grossus Maximus bringing you part 5 of the 2D dynamic lighting system tutorial. Now in this part of the tutorial, we are going to be focusing on making vibrant lights and normal mapping with specular. So, let's begin. Now the next feature we're going to be showing is vibrant lights. Now vibrant lights makes the lights way brighter than it is, because right now it's kind of dim. And this is a suggestion made by OneArbTrex, so thank you very much OneArbTrex. This is personally my favorite among all the features that I'm going to be showing you guys right now. And so to do this is actually not that hard. All you have to do is, instead of drawing a rectangle, so we'll comment this guy out, we are going to be drawing the application surface. So we just say draw surface, and then we say extension, and then here we say application surface, and then we say Vx and Vy. And then we say 1 for the X scale, Y scale, 0 for the rotation, color will be color, just like what we did here. And then we say that the alpha is equal to 1. Now, we're not yet sampling the application surface, so we need to be changing that, because if we look at the light, we could see that we have removed the sampling part. There's no text, vertex text coordinates and stuff like that. So we'll go to some random shader. I'm going to go to shad surf, but you can go to the default shader, and we're just going to copy this guy and paste it back here. Anyways, we're going to go down to this guy here, just copy this, put it here, and then we go copy this vtext coord, put it down here in this varying text, and then here we just copy this vec4 frag and just put it down here. There we go. And then we don't need this guy. Bye-bye. And next, we go to this frag, and we multiply the frag to the GL frag caller. And if we run the game, you'll notice that things look a little bit different now, but this is not the intended result. So to fix this, we'll need to go to the object setup, and we'll go down to this guy here. And in this GPU set blend mode extension, instead of saying BM destination caller, we're going to be saying BM destination alpha. And if you run this, it looks like it's working, but it looks kind of faded. And the reason is because we made this C dark gray. We have to make this C black. And if you run it, there we go. We got some vibrant lights. Now, the whole place is very, very dark. And the reason why is that because we made it C black. So to fix that, all you have to do is just grab this guy here and put this here. And then instead of color, we'll just say C, let's say C white. And then we just say 0.2. And this will give us some ambient light in the background. And there we go. Vibrant lights. As simple as that. Now before we continue to the next feature, let's clean things up a little bit. Remember we did this before. We drew the application surface as such. But we actually can remove this guy here because we already drew the application surface to the shad surf. The next thing we're going to be doing is that we're going to be trying to change the light intensities, because I think the light's a little bit too bright. So what we're going to do is that we're going to be just making the strength, let's say 0.5. And then we're going to go to the shader light. And instead of multiplying the U strength to the strength like so, we're going to be just copying this guy. And then we're going to just say +1 minus U strength. And then if we run this game, we would see that the lights are now not so bright, but just bright enough. Let's try to go to our lights again, and then we're just going to make this, let's say 128. And then if we want to make it even dimmer, we can actually make it all the way to 0, and it's going to be a pretty dim light. We can actually even change this. We can make the range from -1 to 1, and then we can set this strength to -1. And now we have this very, very dim light. So if you want a very dim light, this is one way to do it. But if we were to add all these lights up together, it becomes really, really bright. So for those who want to understand what I just did, how I made vibrant lights, basically, instead of adding all the lights together, then blending it with the wall, I took each light and then blended them with the wall before I added them all together. The reason why this works is because when you add all the lights together, it maximizes to 1. If you add a light that's like, let's say, strength of 1 with another light with strength of 1, it just gets capped to 1. It doesn't go beyond, it doesn't go to 2. But if we were to multiply it with the wall, then that strength of 1 will be decreased. And if it does go beyond 1, well, that's when it's going to be super bright. That's when you're going to be getting a white light. Now, the next suggestion comes from one arm T-Rex again, the same one who suggested vibrant light. So thank you very much for this second suggestion. Now, for those who don't understand what normal mapping is, basically it makes our walls look 3D. Because right now, it basically looks like a wall that has just a wallpaper smashed on top of it, but it doesn't look like actual brick. So if I were to light it up, it just looks like a flat brick texture. So here's a preview of what we're going to be getting once we add normal mapping. Notice how the wall seems like it's popping out, like it's 3D, and yet it's not. And that's thanks to normal mapping. So we're going to be showing you how to do that. In order for us to start with normal mapping, we first need to have a normal map, like this. So it will look something like so. And the way I created this was I used this program called Lighter. You can actually get it for free. It's in itch.io. Just check it out. I'll put the link down in the description below. Now what I did was that I made a tile set of this. So this is the sprite, and then I made a tile set, which looks very similar to the regular back wall tile. So if you check them out, they have to go exactly the same. Now we go to our room editor, and then here, what we're going to be doing is that we're going to go to our back walls. This is our back walls. And then here in the back walls, we're just going to be duplicating these tile layers. And then we're just going to be calling this back wall, let's call this normal. Okay. And then in this normal, what we're going to do is that we're going to be grabbing this, instead of saying TLE back wall, we're going to go to TLE normal. And just like so, we already create the normal mapping. Now we don't want to be drawing this normal map directly to the game. What we want to be doing is that we want to be putting this onto a separate surface. And then we're going to be referencing that surface later on. So to do that, we're going to be doing something similar to what we did with the backgrounds. We're going to be creating a begin and end function before it and after. So we go to object setup. And if you recall, you would see that we have this step right here. This is what we did with the background. So we're going to be copying this and we're going to be pasting it. And then we're going to be making some changes. So like the first change, we're going to be removing this. We don't need the background too. And we're going to be changing this to normal. Make sure that this is the same label as the one here. And then instead of BG layer, we just call this N layer. And then we copy this and then replace this with N layer. And then instead of BG begin, we'll just say N begin and end. And we just copy this, paste this here, copy this, paste this here. And then we're going to be removing this because we don't need this. So bye-bye. We're going to be replacing it with something else. So first of all, we need to be declaring what our normal surface is. And we're going to make it a global. Global.nsurf. So we're going to be asking ourselves if this surface exists. So what we're going to do is I'm going to say if the surface exists. And then we're going to say global surf. But rather, we're going to be saying if it doesn't exist, then we're going to be saying that global nsurf will be equals to surface create. And we're going to be putting here 320 by 180. Make sure to change those values accordingly to your game. Here, we're going to be saying surface set target. And then we're going to be saying global nsurf. And then here, we're going to say draw clear alpha. And then here, we're going to be saying C white 0. And then here in the end function, we're going to be saying surface reset target. And we're done. If we run the game, you will notice that nothing changed. And that's good. That means we were able to successfully draw the normal map onto the normal surface. And that's why we don't see it. Now, since we are moving our camera, we can't just simply set this target to the global nsurf. We will need to change the matrix, the world matrix. So let's just go back to the draw event. And then if you recall, we had this matrix set thing here. So we're going to be copying this and then we're going to be pasting it right here. So right after setting the target, we set the matrix to this. Now, the thing is that this Vx and Vy are not global variables. So we need to make a global variable version of these guys. And so we're going to be just grabbing this and just going to be saying here that the global.vx is going to be equals to, let's say 0. We're just going to be initializing it here. And then we say Vy is also equal to 0. Then we're going to be grabbing this. We go to the step event. Remember where we set the Vx, Vys. And we just say that this is going to be Vx and this is going to be Vy. And then we just have to copy this and paste this here and here. In the end, after surface reset target, we make sure that we set the world matrix back to original. So we say this is 0 and this is going to be 0. Then these three are going to be 1. So let us now pass the normal surface to the shader. And to do that, we're going to be doing it to the light shader. And so we're just going to be copying this and pasting this. And we're just going to be changing this to UNMap. And then change this to UNMap as well. Now, be careful that we're not going to be using the shader get uniform. We're going to be getting shader get sampler index. And then we go to this draw function, the draw event. And here, we're just going to say texture set stage. And we're going to be saying u nmap. Now we forgot to make this a local variable. So we say var nmap is equals to u nmap. And then surface get texture, and we put here the global dot n surf. Next, we will go to the shader light, and then here we're going to be adding a new uniform. So we say uniform, and we say sample 2D, and here we're going to say u n map, and then we're going to be copying this, paste it, and then we're just going to call this norm, and then instead of GM base texture, we're going to be saying u n map. And to test whether or not we have done everything so far correctly, we'll just exchange this frag to normal temporarily. And what we should see is our wall has now been replaced with the normal map. And if we move our camera, it should remain there. So we know it's working. Now we just have to change this back to fragment, because that was just for us to test whether or not it's working. So the next part requires us to have an understanding of how normal mapping works. So let's look at our normal mapping. So this is our wall normal map, and the first thing you might be asking is, why is it so blue? Well, what blue means is that it's facing towards you. And since majority of the wall is facing towards us, it looks blue. Now what about the other colors? Like, notice how this side here looks kind of reddish? Well, that's because anything that's facing towards the right is reddish, whereas everything that's facing above is green. So in essence, this is actually the X, the Y, and the Z. Now so far, the way we calculated the light intensity is how far away we are from the light source. So let's say that this is the light source and this is the wall. We can expect that this will be brighter than if we are in this wall here, because this length here is smaller than this length. Now, what we're going to be calculating next is if the wall is facing towards the light. So in this example here, this wall is facing directly towards the light, whereas this wall here, well, this wall is facing upwards, but the light, if we were to draw an arrow towards the light, it will be going this direction. So obviously there's a little bit of a difference between where it's facing and where the light is. Now, in order for us to calculate this difference, we are going to be getting the normalized dot product of these two. So a property of the dot product is that if we have two normalized vectors that are facing the same direction, so we get this dot this, we should be getting 1. If we get a dot product of one normalized vector is facing upwards, and let's say another one's facing 90 degrees away, this should be 0. And then if we get a dot product of something that's facing, let's say, upwards, and we get the dot product of something that's facing downwards, the complete opposite direction, this should be equals to -1. So we're going to be utilizing this property. Okay, so I think we're now prepared to go to code. Now, first of all, don't get confused with this norm. Just because it's called norm doesn't mean it's normalized. Think about it this way. We have sampled this from the normal map, which are values of RGB from 0 to 1, with the center at 0.5. Now, we want the center to be at 0. So what we're going to be doing is that we're going to be saying minus 0.5, as simple as that. Now, we have to make sure that we're going to normalize this. So we say normalize, and we're going to be bringing this all the way here. And also, don't forget to say .RGB, because we only want to be normalizing the RG and B values. We don't want to be normalizing the alpha. And so we have to change this vec4 to vec3. So now we're going to be getting the vector from the wall to the light. Now, if you look at this distance here, this pause minus u pause, this is already that thing, except that it's going the opposite direction. This one's from the light source to the wall. We want to have the wall to the light source. Also, this is vec2. We want to have it in vec3. So what we're going to do is that we're going to say vec3, and we're going to say L norm, meaning light norm, and we're going to be saying normalize. Don't forget to normalize. And then inside that normalize, we're going to say vec3, and we're going to say this.x, this.y, and we're going to just put some arbitrary value of 32. Now, remember that this is going the opposite direction. So what we're going to do is that we're going to be negating this. So we're going to say negative this.x. Now, normally you should be also negating the this.y, but take note that in our normal mapping, the green value is pointing upwards, whereas in GameMaker Studio, the Y value is pointing downward. We don't have to put a negative sign there. Next, we're going to be getting the norm and L norm, and we're going to get the dot product. So we're going to say float norm str is going to be equals to the dot of norm and L norm. As easy as that. And then we're going to get this norm.str and multiply it right here to the str. And we run the game, and we should see that our wall is now being, you could kind of tell. It's a little bit hard to tell, but there is a nice shadow effect with the wall. So now it looks more 3D. If I were to remove this, just have a contrast between the two. This is now without the normalized map. Notice how flat now it looks like. Let me put it back again. And let's see. There we go. You see the difference. So there are things that we can do to make this even better. And that is by adding specular. So specular is an additional lighting effect. What we did earlier was the normal mapping, which we used to determine whether or not the wall is facing towards the light. Now specular tells us how that light bounces off the wall and goes towards our eyes. Let me just demonstrate to you what's going on. So let's say that this is our light source and this is our wall. Okay? And let's say this is our eyes over here. So let's say that's our eye. Now, we're going to be having our light going all the way here to the wall, and it's going to bounce off here and it's going to go directly towards our eye. So this part of the wall will be shiny. Now, if the light's going to be going towards this direction and it's going to bounce off away from our eyes, this part's going to be dull. To do this is pretty simple. All you need to do is find that direction of that light, which we already have. It's already this, but the opposite direction. So we have to reverse it once more. And then we just have to get the reflection of that. So to get that reflection, we are going to be saying vec3 reflection is going to be equals to reflect. And there are two things that we need to put, two parameters. The first one is the incidence vector, which is the vector of the light to the wall. So it's basically L norm, but we have to multiply this by -1. So just say negative L norm, and then we say norm. Now to get the strength of this reflection, all we have to do is actually just, instead of saying vec3, we just say float, and then we say ref, and then we say dot z. Now the reason why it's dot z is because, let's go back to the diagram. Remember that our view angle is always facing down. So let's say this is our view, and then this is that's our wall. So anything that's facing upwards is going towards our eyes. This is basically the z value. So all we have to do is get the z coordinate of this reflect, and that is our reflection value. We're going to be getting this, and we're going to say plus reflect multiplied by the call multiplied by the str. And if we run this, this should make our walls look super bright. That's because we did something that's a little bit wrong. We want to be restricting this reflectivity value so that anything that's pointing upwards will become 1, but as it goes further away from 1, it's going to be dropping down to 0 faster. And what we're going to do is that we're going to be getting the power. So what we're going to do is to say pow, that's the function, and then we're going to be, let's say we're going to be giving it, let's say 2. And don't forget to say maximum here to 0 of the reflect, because this value here can go negative. Negative times negative becomes a positive number, and that's not what we want. We just want it to get clipped at 0. So that's why we need to do the max. And then we say, let's say power of, not 2, let's say 16. 16 is a sweet number. And if we run this, we would see that now that shiny value is a little bit less. It's more restricted. So now we got this very super shiny looking thing. Now, if you think this is a little bit too shiny, well, that's where we're going to be multiplying this, let's say by 0.5. I think that's a very good number. And there we go. We've got ourselves some cool normal mapping plus specular. And so we got some cool effects here. Now we can always just adjust the reflectivity, how strong it is, just by these multipliers. If you want to make it a little bit less, let's say 0.2, there we go. So it's not that reflective. The more reflective it looks, the more wet the wall looks like. So if you want it to look wet, then go ahead. If you want it to look a little bit dry, reduce that value. So there's one teeny tiny problem which I haven't addressed, and that is, let's say we have an object. let's say it's an object robo, and this is going to be like our character or whatever, maybe our enemies. And so let's say we drop these enemies or robots here into the game, and make sure that this is behind the lights, so it's a layer below the lights. And if we were to run the game, you'll notice that yes, the light is illuminating these robots, but somehow it seems like the wall textures are going on them. And that's not the wall texture, that's the normal map affecting them. And so we need to fix this. And the way to fix this is actually pretty simple. All we have to do is we are going to be creating a new shader. So we just go to the shaders here, and we say create shader, and we say this is going to be shader norm. And then in the fragment shader part, we're just going to be copying this glfrag color here, put it over there. Let's just say this is vec4 frag. And then here, the glfrag color, we're going to be saying it's going to be vec4. And then we're just going to say 0.5, 0.5, 1. And then we're going to be saying frag.a. 0.5, 0.5, 1 represents a normal map when the surface is looking directly towards you. Now that we have this is where we're practically done with the shader norm. We're going to go to object setup, and then in our draw event, let's just do it somewhere below this shad surf thing here. We're just going to be saying surface set target, and we're going to be making this n surf or global.nsurf. And then we're going to be saying shader set, and we're going to be setting this to shader normal. And then after this, we're going to be saying with object robo, and then here we're going to be saying draw self, and then we just say shader reset. And one last thing, we just say surface reset target, and there we go. If we run this game, we would see that the robots are now not being affected by the normal mapping, which is cool. There we go, look at that. Now the back wall looks super amazing now, but when you look at the front wall, there's a really big contrast between the back wall and the front wall, and that's what we're going to be working on in the next tutorial. We are going to be working on how to be making edge lighting on our walls, and also how to create a bloom effect, which is an extra post-processing effect for our lights. So this concludes part 4 of the 2D dynamic lighting systems tutorial. The last 2 tutorials wouldn't have been possible if it weren't for you guys. So I thank you very much for all those who have given me suggestions, and to those who have subscribed, and those that will subscribe. So please do subscribe if you haven't yet, and like if you like. Thank you very much, and I hope to see you guys next time.